Hello, and welcome again. In this video, we will look at communication protocols, understand why we need them, and explore their different types and their advantages and disadvantages at a broader level. First, let's start with the why. Why were communication protocols designed? In edge computing, devices like sensors, microcontrollers, or MCUs, and other embedded systems need to exchange data effectively. Protocols were developed as a set of rules to enable this communication seamlessly and universally. There are two main types of communication protocols: parallel and serial. Parallel protocols allow multiple data bits, often 8, 16, or more, to be transmitted simultaneously using multiple wires. This method is incredibly fast due to the concurrent data transfer. However, parallel protocols, despite their speed, have some drawbacks. Firstly, they require more physical space for wiring, making them less suitable for compact embedded devices where simplicity and cost-effectiveness are key. More wires also mean higher manufacturing costs and potential for interference and signal degradation over long distances. In contrast, serial protocols transfer data bit by bit over 1 to 4 wires and are thus more adaptable to smaller, integrated systems typical in edge applications. The key advantage of serial protocols is their simplicity. They require fewer wires, which reduces the complexity and the cost of the hardware. They are also more effective over longer distances, where parallel transmission can suffer from timing issues and crosstalk. The main disadvantage of serial protocols: speed. Since data is sent bit by bit, serial transmission can be slower than parallel protocols, which might be a concern in applications requiring very high data rates. Serial protocols come in two types: synchronous and asynchronous. Synchronous serial communication uses a clock signal to synchronize the timing between the sender and the receiver. This ensures that both the devices are aligned on timing when sending and receiving data. This is efficient, but requires both systems to maintain precise timing, which adds to the complexity. In contrast, asynchronous serial communication doesn't require a clock signal. Devices agree on data rate and format beforehand, but are free to send data in chunks separated by stop and start bits. While this reduces complexity, asynchronous transmission is typically slower and less efficient than its synchronous counterpart. In summary, while parallel protocols are fast, their physical demands make them less ideal for modern, compact edge systems compared to the more streamlined serial protocols. Between the different serial protocols, synchronous serial protocols are faster and more reliable for real-time applications, while asynchronous protocols are more flexible and simpler to implement, making them well-suited for basic input-output operations in edge devices. In the next video, we will look at UART, an asynchronous serial protocol, and discuss its features, its working, and its wiring. See you there!